login will call a load of participants from local database, HTML5 database from participant manager. So after that, the connection manager asks the locator. This is a SOAP web service, which is given by ICS. After we give the locator, we log to the ICS with login and password. This gives us a token, and with this token, we connect to the ICS. And this is the end of the login process. We send a connect success. This is an overview. We will see in detail what we do at the login after. So the middleware is designed to connect to the OT outside or inside the enterprise. So it is also designed to restore the connection if the network change. If we switch from public network to private, the middleware is able to restore the connection to the OT. So, as we discussed in previous diagram, the middleware connect to the OT on several server components. So we have the SOAP service. This is the ECS part of the OT which deal with. We also have the REST services, which is also the ECS. In fact, you probably know that the first version of the OT, when it was only ICS, was SOAP services. After that, they decide to change the technology to REST services, but not all the service given by the SOAP are disponible in REST technology. So we had to keep a branch, a link to the SOAP services, and also for new service and few one which have been replaced, we use the REST services. After that, we also have the ACS services. So in ACS services, we have the VCS and the Action API, which are both call of URLs. And we also have the device management. So we download the XML file where are described the information about the softphone, the information for the SIP connection. So we download it at the end of the login process, and we give it to the OTCPC, and with that file, the OTCPC start initialize in the SOAP layer, not SOAP, in SIP layer.
Oops.
In SIP component. So as I said before,
Welcome to the Alcatel-Lucent Conference Center. At the tone, say your name and then press pound.
What?
At any time, you may press the pound key twice for a list of options.
the provided information, login and password, or the key received from Kerberos system are provided to the first login, which is done to the SOAP system, and the SOAP system. The SOAP services return an ALC station ID, which is used to log in to the REST and also to the REST API and also to the ACS server. Just to have a look. So, as we have done yesterday evening, I connect to the OTCPC. So in the log, we can see the login request there. Here we have the log we discussed yesterday with the API, which means this is the entry point of the method, which gives the services to the UI part. So this is the login, and after that we have the locator there. Every services, oh, we don't see. Every service is provided by the ICS. URL, after that the URL where the services are disponible. As you can see in URL, there are some versions. The different versions are because some services did not follow the life of the OT. They have been freezed, and that's why you can see 7.0, for example, for ICS presence or ICS UDA. Or sometimes it have been it have evolved on server side, but not in the client. So here you have the log about it. And what I want also to show you
Привет.
is the ALC here. Here is the framework session ID, the ALC session ID. Well, sometimes you can see a different name. It have OTUC session ID, ALC session ID, and here in log in the SOAP request FW station ID. So you have to know that the name can be different. It depends on the name of the component of the OT component. So this is one example of a session ID. So this session ID is given by the SOAP, and after that we use it in in the rest of the login process. So we give it to the rest and also to the ICS. Okay. So as we discussed yesterday, the middleware which is embedded in OTC web has no trick, no link, no specific link. It is only an instance of the OTC object. So when you have a OTC web browser which is running in a browser tab, if you do a refresh, all the cookies present will stay. So that's why one first thing we have to do is to clean the login because the ACS component deals with cookie to allow request to be executed after the ACS login. In fact, the ACS login request put some cookies on our side, on web browser side, but at the logout process or refresh a page, it is not erased. So we have to erase this cookie by ourselves to be able to do a fresh login. Else, previous cookie will be used, and if you change the conversation, you won't be in the right conversation. So that's why we have to delete all cookies. And you have also to know that the OTC web connect to OT only on the ACS part. We don't need to connect to the ACS because the login is an anonymous login. So instead of the login method for the OTC web, we use the join conf using access code. This is we use the vanity and the nickname which is provided by the user. So after that, we can go deep in login process. So you have to know that the middleware allow OTC PC, OTC iPad, OTC Android, and also OTC web, yes, also to challenge the certificates. As you have seen, we have just looked on the log. When the middleware retrieve the locator, here we retrieve a URL for locators. So every services have a single URL. So we send it to the to the UI, and we stop the login process. We wait for a go from the from the UI. We send this event on connection manager server and info loaded. So this event provide all the services and also all the URL for these services. And usually in OT, every services have the same FQDN, except especially when you are outside the company, when you have OTES, the Teamwork ACS services is different. It's sometimes different from OT server. So we provide this URL to UI to challenge every certificate. So after the user,
in fact, middleware is not able to do
yes,
to do it itself.
Yeah, the middleware is embedded. Is running in a web view, so you don't have access to native part, and is not able to ask for the. We are not able to ask to the user to accept the certificate. So the UI part must do this process. So we load the information about service about the server, but it is the native part which accept the certificate. So after the user has accept all the certificate, it is the pop-up we have after I have clicked on login earlier. The UI call login after get server to to continue the login process. So we have stored the information about login, and we continue the login process. So this is what I just said. And to continue the login after the process. Okay. After that, when we are connected, the middleware and OT server provide a keep alive mechanism. In fact, there are two keep alive. The two keep alive are for each OT component, one for ECS and one for ACS. Oh, okay. The order of my PowerPoint is not good. So low layer keep alive. This is what I'm talking about. So the ECS provide not the ECS. For the ECS part, the middleware provide a keep alive. We do a keep alive. We do a request every 2 minutes to the ECS to detect if the ECS is still there. If it doesn't answer to the request, so we try to reconnect automatically. And we also do this keep alive also when the detection can be more quickly than the 2 minutes. For example, if we did a request for the ECS during these 2 minutes, if this request fails, then we detect the fail and we go in reconnection process. For the ACS, every every 3 minutes, by default, the ACS gives us a keep alive. This is on the side. So it is the ACS server which gives us a keep alive in the event pipe. And if the middleware did not receive this event during after the 3 minutes, we decide that the event pipe is broken, and so we break it. We manually break it with the code, and we start a reconnection process to assess. The keep alive is also used when we change the login, the network. So if we change the network, the keep alive, if the keep alive detect that we are not connected anymore to OT, it will try to connect to the other type of connection. So if we are actually on the enterprise network, it will try to connect to the public FQDN of the OT. And on the other side, if we are already connected to internet, it will try to connect to private FQDN.
It's also because of some mobile devices, or even using OTCPC, you can put your OTCPC in hibernate mode and open it again at home, and then you are no more inside the enterprise, but automatically when the PC is up again, then middleware can try to reconnect automatically using the public FQDN while he was connected before on the private one.
So connection manager and also low layer are used to restore the connection. Every connection, every low layer connection, try to restore by itself its connection. So if the connection to ICS is broken within 2 minutes, so we try in low layer to restore this connection. We do not break the ACS connection. We are focused on the low layer connection, and if there is a mechanism to change the retry after 20 minutes of try. For the ACS connection, we have also the same behavior. If the event pipe is broken, we start to try to repair the connection at low layer, and and well, we have a tab with time to be less frequent, to try to reconnect less frequently when the repair fails. These are second.
And this part has been done also for tablet devices in order to don't consume all the power.
Yeah. Yes. The goal of this tab is to try to reconnect as shortly as possible the first time we have a change in the network. So if the Wi-Fi is not working very well, we have to reconnect as soon as possible. And if you get your tablet outside the enterprise and no more Wi-Fi will become available, we don't need to try anymore reconnect as often as the first second of the disconnection, because the reconnection process on a few tablets dries the battery because of the Wi-Fi which try to reconnect. So that's why we have this kind of behavior. So when the middleware, so this is low layer part, but why I said connection manager is also involved in restoration of the connection, it is because when we did not success in reconnection, after a few fails, we try to connect. It is what I said just before. We try to reconnect to the other FQDN, public or private, and when we does it, if we are we have to re-login from the upside of the up layer, the connection manager layer, because we need to challenge the certificate because the FQDN of service are not the same in public and private networks. So that's why when we detect a change of network type, we send an event to the connection manager to say, oh, we have changed the type of network. It is your responsibility to re-login and to allow and to be a re-login from the upside of the services. So that's why you will see in the on ECS login error callback in connection manager, you will see some reconnection process. So you will have a reconnection process in for ECS. It is in ECS protocol, so we should see a keep alive. So we have a method to test if the connection is there, and we also have the method which is called for the keep alive. So as I've said before, the keep alive to ECS is done by the middleware. It is the middleware which tries to reconnect to the ICS. It is not the ICS which says that the connection is fallen. This is for the ICS part, and for ICS, the low layer reconnection is a repair process. You have a repair method, which is there. This repair is called when the ACS7 pipe is broken. And this is for the low layer reconnect. So if the low layer succeed in reconnection, so only on connect success is sent by the connection manager, and the connection manager does not have any more treatment because why is there on connect success when a reconnection is done? It is because when we reconnect to the ICS, we receive a lot of event, a lot of reconnection event, which gives the state of the user. So we receive if there is a call, a meeting, and so on. That's why we send a connect success, because we also receive the call log not from the ACS part, but from the ICS. And so this is the low layer part, and for the up layer we have the connect success, and so you can see for example, server unreachable, we put the state of reconnection and we put a timer. The timer is because of HTML request which can go in a deep process of fail. So the timer allow us to be to have to spend a few time between two requests to server. So the get server is the method which retrieve the locator. So this is the low layer, and in general, what we receive is error bad framework session identifier when the network has been changed from public to private. This is the use case. I put my computer to Hibernate mode, and I wake up at home, and when we try to reconnect, the session ID will be expired. Okay, will expire. So we receive from OT server a bad session identifier because it is expired. So we detect it is a reconnection. So we detect it is an expiration of the session. So we send it to the UI, and we said we have been already connected, so we will reconnect. And this is done there. We reconnect. Okay. Okay, so this is the reconnection process.
It is the do pipeline ECS which done the reconnect.
It depends. In fact,
in the code you.
Yeah. Well,
it is this line. Do pipeline ECS.
Well, at this the session framework can be. We don't know at this stage if the session has been expired because we are outside, or if because we are inside, but we did not connect. When you restore your PC, you can be at the company. You can be still at company, but only disconnected from the network. So as you were disconnected, the framework session has expired. So you wake up, and we know the session is bad, but we don't know where we are. So we try to do a keep alive to reconnect. And it could be enough if we are on the same network as before. And we will have a fail if the network is not the same, and we will reconnect. We will have host not found or something like that. So we will have server failure unreachable probably, and then we will get the locators. So we also have the ability to be well. We discussed about the PC which put us in Hibernate mode, but you can switch from Wi-Fi to another Wi-Fi network, or to the wired network, and this kind of change is not natively given to the WebView, even in OTCPC WebView or iPad. So we have to have a specific treatment inside the OTC client. So this is so as we are not able to know what's happened on network interface inside the WebView, we decide to provide a common method to every client, which did not give us a lot of information, but it allows the native part to tell us the network has changed. Something has changed in network and interface. So this method is a check network connection provided by a connection manager, and then the UI detect any change in material interface, network interface. It detects that you switch off the Wi-Fi, you plug in a wire in your interface, and it calls the check network connection. So as a result, we will try to do a reconnect. So we will, in fact, it's not a real reconnect. We do a keep alive, and if the keep alive fails because we are not on the same network, we will do a reconnect. After that, we already discussed about FQDN private and public. So why middleware need to know at the beginning of the process the private and public address? Well, it is a question somebody asked me, so that's why I put this slide on the presentation. So we have to build the sub-services, the REST, the ACS, to send. So we need to send URL to challenge the certificate. This is what we have seen. To build the device management, and we also provide the UI part, the native part. We also provide URL to some resources, so avatar, voicemail, and document. And this is the middleware which build the correct URL to these resources. So it is the middleware which change from public to private to allow the UI part to download photo and avatar and so on. So, and one single URL is used to every subservice. One single FQDN. So now we can we have discussed about main principles of the connection and reconnection. So we can see more in details diagrams. So this is a login which succeeds to the ACS. We have got the UI part, we have got the OT server part, so ECS and ACS, and between these two components we have the middleware and the connection manager. So at the beginning we have two variables inside the connection manager. These two variables are used to store the state of the connection to each component of OT server. So we have ACS connection state and ECS connection state. So at the beginning we are disconnected from every component. And first step, the OTCPC asks the middleware to do a login. The connection manager loads the locator with the getServer method we have seen in logs. Locator are loaded. So at the result of the getServer, we have the on it is not the good one. Yeah.
Because the other was for tablet before they use the same way. In fact, at the moment they were managing certificate by their own Cordova.
Yeah. This is the right diagram. Well, at the beginning, OTCPC did by itself the check of certificate, but that's why on the first the login after getServer was done by the middleware at this time. It was so the second this diagram is for the iPad, and the first client who asked us to have the ability to challenge the certificate was the iPad. So that's why at the beginning we did it for that. And the first step of the PC was to ask you for the public and private FQDN at the login, so you still have this to provide, and they did the challenge to both URL, and we the OTCPC wasn't able at this stage wasn't able to connect to OTES. And so we did the login after getServer for them, but since this diagram it adds this change, and now they use the same behavior than the iPad, and then they are also able to connect from outside to OTES. So let's start.
So this diagram is available now for both iPad on all tablets on PC, in fact.
Yeah. So it is the same as the previous one, except the entry method is login with session ID. So we will use login and name password, which is the more used login process. So we have the UI part, we have OT server part, the connection manager, the initial states. So the UI calls the login with name and password. We get from ECS all the locator. After the locator has been loaded, we return on connection manager servers info loaded to the UI. So it is the event there. We have sent to the we send the list of server to be challenged. So security management inside the report. So when all the certificate has been accepted, the OTC PC and the iPad ask to the login to continue. So they call login after get server. So we call an ECS protocol start method, which is the low layer to login process to ECS. We have a login success. On the login success, we now connect to the REST part of the ECS. To do the connection to the REST part, we firstly need to delete the old session. So it is a workaround to bad behavior of the ECS component. So we have to first delete the old session to allow the ICS to clean its context. So we firstly delete. So you will see an error in logs. Well, I believe in logs we do not have a spot on the error, but in the debugger we have it because the OTC ICS give us 403 forbidden error. So that's why the debugger saw it as an error. So you have to know it is a normal behavior. So we delete the old session there. And after the session has been deleted, we call what we call the hello request, which is there. We call it hello because we have the name hello in the name of the URL. Well, that's it. And here you can see ILC user ID. This is one name of the session ID. So we call this URL with one parameter, which is the session ID, and the goal of this URL of this server service is to put the cookie. So as a result of this request, a cookie is set on the web view, and this cookie is used after in every request set every request which are sent to the REST part of the ICS. So this is the hello set new session ID. Okay, as a result, and we have a callback. So after that, the login is the ACS part. So we have a login to the ACS with also the session ID. That's it is there. So you should have a log which REST loaded, and I believe there is a log which says that now we are able to connect to the ACS. But the first step of the connection is there. So we have login to access method in connection manager, and so the connection to the ICC. And the real connection is this request. So this request with some param, we have sign in action. The external out cookie is the session ID, session framework ID, so which is named OTUC SSO here. Person 3D is I believe in these three letters are the HTML encoded equal letter. Okay, so after the login succeed, we have an ACS login success. So we put inside the connection manager the state of each server, and we send an on-connect success. As a result of the on-connect success, the connection manager downloads the DM, so it is the file with the SIP information, and we send it, well, it is not shown here, but after the device management file is loaded, we send it to the UI part, which start the stack, the SIP stack. And we also do a get REST session locator. This is to get the URL where the REST services are available. Okay, this is the connection. So we have the login success. No, we have the login to ACS, and we should have. So as I said before, we have the login to ACS. We do the sign in. The sign in put the ACS cookies, and when this request succeeds, we open the event pipe. We receive a few initialization data in the event pipe, and after the initialization data, we have the login succeed. Login succeed here. So the login succeed is an event we receive in the event pipe. So you can see that the middleware do few things between the request from UiPart to login, and when we say to the UiPart we are ready to work. So that's why we have to say okay, we send a login, a connect success, which is there. Well, this is not the real.
It is usually just after.
Yeah, it should be just after. So here we have a test. Well, you will see in the code, but we have a test to, as you have seen, we have two parts of connection, two kind of connection, one ICS and one ACS connection. Both of them can take a few time to execute. So sometimes we have seen that the other connection has been broken after the end of the login of the second part. So that's why we try to reconnect before we try to make a little request to be sure both parts are connected before we send the unconnect success. We see we did it because we have seen on site some I don't know
there is
if
some
it
case,
was, yeah,
there is
if
some
it was,
case of switchover. So the OpenTouch, in case of high availability, there are some switchover, and in fact middleware was connected, and he detected the disconnection because ACS or ICS was done, and we try quickly to reconnect. We success to reconnect to ICS, then using the session ID obtained, we reconnect to ACS, but in fact the first connection to first server to ICS, it was not really good because ICS was done again, and then when ACS say okay you are connected, we check again if we are still connected with ICS, and ICS is again done. So that's why we check this kind of thing. Okay, we are connected to the second server, but we check again if we are still connected to first one.
Yeah,
things like that.
okay. Just to
just maybe you can show the event type. There is a command maybe for opening the ACS event type. It was maybe just So
this is the result. We
it
say
is
the
the
event
result.
pipe
It's
is
the
open.
first server interface dot set user language. Always it is event from event pipe. Was OpenSE function. Oh, this one.
Yeah.
So
we have the result. So we have the signing which puts the cookies. So we send it, and in the logs you can see we have some queue to send Ajax requests. So you can see request ID 1, the URL asked. So you can follow with the ID one request. So you have just before send method, which is called just when the WebView decide to really send the request. It is not well. We have some issue with the timer of request. When you put a timer on Ajax request, the default timer starts when you ask the system to send it. And if it takes time to send it, the timer is still on. So that's why we decide to have our queue. So you can follow the request. So ID1 in network Ajax queue. So we have three queue. One for HTTP proxy jQuery Ajax queue. So this queue is for the REST request. You also have a SOAP proxy jQuery Ajax, which is a queue for the SOAP request. So let's start again with the action, sign in. So we saw this is the first request, the ID1 sent to the ACS, and okay, here we have network Ajax queue down the request 1. So this is the callback of the success of the request. So we said login callback success. So we said the login request is a success. So we ask to open the event pipe with external hooking, auto hooking. So this is the OpenSE method which open the event pipe. And so on. Okay, you have a show cooking method, but take care about it because depend on client. On few browser, it doesn't have access to cookie, so it can be empty in the logs, but not empty in reality. So take care about the information shown by show cookie. Well, we left this this log because it can be useful when it is completed, but take care if it is empty, it is not because it is really empty. What is well, it is to be used only when it is filled. When it is filled, you can see the expiration of the cookie and also the domain. As I said yesterday, the no login cookie is sometimes due to rehosting of the server and the domain has changed. The real domain has been changed, but not everywhere in configuration. So sometimes you can see the old FQDN domain, old OT server domain, and then the cookie is present but is not valid for the domain. So the ACS, the buddy console, reject the request. Oh, that's it. So now let's have a look on an error. Oh. So this is the first login. This is not a reconnection. So at the first login, we can see both server component, ECS, ICS, the UI part, the connection manager, the disconnected preview state. So the native part calls the login to connection manager. We can get the locator. The locator are received. The login after get server should now be not inside the connection manager, but should be to the UI side. And after the login has been loaded, the server has been loaded and all certificates accepted, we start the login with login and password to the ICS. So if the password is wrong or expired, so we have an error on login ECS error. The on ECS login error is called, and as we were in a previous state disconnected, we send a connect error, and that's finished for us. The UI part show an error as it was unable to connect to the server. So now same, but if we are this one on top. Same behavior, but connection to ECS not possible. So we have the load of the server, the login, the load of the server, the connection to the ICS, the connection to the REST part. So we try to log in to the ICS server, and the ICS method called is on ICS login error. So we go in this callback when we have the no login cookie error. So we send an error. I do not have any diagram with reconnection. So I don't know. See. Well, let's get what. And if we were already connected there and there, so there, already connected, in the error callback, instead of sending the connect error, we should have a reconnect process. So the get server, we should have a link like that to restart the reconnection process. It depends on the initial state of the connection. I will do a diagram for that. Okay, so for me, for login, I believe I discussed all the subject. So, Eric, do you have something more
about this subject? Maybe some question?
No questions at this moment.
Not now. Just now, no, I don't have questions. Information must be absorbed in the brain.
Okay.
So maybe we can make
We make a little break.
5 minutes, and we will start with participant manager, and we will take we will start participant manager, and we will continue with this other part after this afternoon. So 5 minutes break of 5 minutes. Is it okay for you?
Okay.
Okay, thanks.
Thank you.